Hello everyone, today we are finishing up our chapter on circles. The first 5 sections we looked at were dealing with angles and chords and segments and solving for different parts of our circle. This last section, section 7, is going to be looking at the equations of circles and how we use equations to graph. Now we did this earlier in the year when we were graphing lines using the equation y equals mx plus b, where we could pull out different parts of our line, the slope, the y-intercept that would help us to graph a line. Now similarly, there's an equation of a circle, and you may have seen this before, that we're going to start with. The equation x squared plus y squared equals r squared. And the way we're going to look at that, we're going to kind of explore this and see where it comes from. All right? The x and the y stand for points on my circle. So if I start with a circle on the origin, we're going to start on the origin first, where my center is at 0, 0. I'm going to pick a point here, and I'm going to call this point xy. Okay? So if I take that point, I'm going to relate it to the equation here, and I want to draw the radius to that point. My radius is r, so there it is on my equation again. And if you think about it, we can make this into a nice little right triangle where the distance along the x-axis is x, because that's how far over my x-coordinate goes, and the distance in the y direction is y. Now if you think about it, since it's a nice little right triangle, look at what we have here. We know that there's a relationship in the right triangle between the legs and the hypotenuse. We can find the length of that hypotenuse r if we square the leg x squared plus y squared, we know equals r squared, which is just what we have as our equation of our circles. We get this using the Pythagorean theorem. Okay, and this is the relationship that our radius has with every point on the circle. I could do the same thing with other points here. If I wanted to find, here's my r again, this time my x would be, let's make this x1, y1, then this would be a distance of x1, a distance of y1, but we'd still get our r squared. So we can use x and y to stand for any point on our circle. Hang in there a second. Okay, let's look at our first example just using that equation that we just talked about, the equation of a circle. Remember that it's x squared plus y squared equals r squared. So when we have x squared plus y squared equals 25, that's telling me that my radius, my r, has to be 5. It has to be the square root of the r squared there. Alright, and if we have no other numbers here, just x squared plus y squared, that means our equation, like our example at the beginning, has to be at the origin. So our center is at 0, 0. Now, these are the only two pieces that you need in order to graph your circle. You need the center and you need the radius. So from here, we know that our center is at 0, 0. Our radius has to be 5. Well, when you graph your circles for me, I want you to not just throw the center and throw a circle around. I want you to actually measure out the radius for me, at least in a few directions. Doesn't necessarily have to be all 4 directions, but go ahead and show me that you actually know what the radius of our circle is. Okay? Not expecting perfection. I don't want you to get out your compass and make sure it's perfect. Just tell me that you know where the radius is and draw your circle there. Okay, let's look at some things. Okay, let's explore a little more. This time we ask ourselves, what happens to our equation if our circle's not at the origin? Okay, how's our equation change? Now the first thing, we use a standard set of variables to stand for the center of a circle. They always use the variables HK, okay? Kind of like we use the pi symbol for pi. Well, for the center of the circle, we're going to use HK. So this time our origin, our circle is moved over and up to HK. but we're gonna remember our formula came from the Pythagorean theorem, so we're gonna use something similar to figure out how our formula changes. Okay, so from h and k, our r, that's our new r. Our r is a distance from between these 2 points. So if you remember our distance formula, it's been a little while, but hopefully not forgotten. The distance formula is you take the x coordinates, x2 minus x1 and squared, and you add the y coordinates, y2 minus y1 squared. That would be distance. All right, so for our circle, D happens to be our radius, r, is going to equal our x2, x1 is going to be, in this case, 8x minus h. I wrote it backwards. Let's try again. X minus h squared. And our y coordinates are y and k. Okay, so this one we have x minus h squared plus y minus k squared, square root of both sides. So let's get it to look like our other formula. If we get rid of our square root, think about what we do here. In order to get rid of our square root, we're going to square both sides. And now we wind up with something that looks like our other formula. I'm going to flip it around. When you square a square root, it goes away. You wind up with x minus h squared plus y minus k squared. And we're going to move our squared over here. Now it looks very similar to our other formula. We had x squared plus y squared equals r squared. Now we just have x minus h, where h and k are still our center points. So this helps us move that circle to the new center point. Okay, we're going to pause for our first question. What formula is used to derive the standard equation of a circle? If you remember. All right, we are back. At the top in the green box, I have the standard equation of a circle, is what they call it. We can use this equation for any circle anywhere, even the ones that are on the origin, and we'll look at one of those at the end. But again, it's x minus h squared plus y minus k squared equals r squared, where h and k are always the center, and r is my radius. And those are the 2 things that we need to graph our circle. So let's look at the first example. We're putting in some numbers here. This is what they're going to look like for homework. We have x minus 4 squared plus y plus 3 squared equals 16. So the first thing you're probably going to jump at is say, okay, I know my radius is going to be the square root of 16. Don't forget that. A lot of people will start putting that as their radius. But r squared was 16, so r has to be 4. That means my radius is 4. The next part is I'm going to get where my center is from my h and k. So my center is hk. Center here. Center is hk, and in my new equation, my h is 4. Remember, that's minus up here, so that might throw you off, so be careful. H is 4, and my k should be minus k. So in order to get this to be minus k, that means k has to be negative 3, because y minus negative 3 gives me plus 3. All right, now I have the 2 parts. I have the center and the radius. So I'm going to go ahead and count 4 over, 3 down. That's my center. And then from here, I'm going to count 4. So I'm going to go in each of the 4 directions, pick up my radius. I think I've got it there. And it's just going to be a sketch of a circle. Okay, do your best. And there's my circle with center 4, negative 3, radius 4. Let's look at another one. All right, let's take a look at this example. This one, if you look at it, you'll say, wait a minute, it's a little bit of a hybrid of the 2 different equations. We have x plus 1 squared plus y squared equals r squared. So I wanted to show you how this equation works with when it's on the origin. It's not quite on the origin, but take a look. All right, so we know that in this form, we would have x minus h squared, y minus k squared. Well, when I have y squared by itself, that just means that my k has to be 0, okay? So I still can find my center at HK, it's just that H, again, we wind up with -1 because it's the opposite. In order to make this positive, my H has to be -1, and my K is at 0. It's on its axis there. My radius, and I forgot to put the number here, that doesn't work. Let's make it a 4. So that means my r squared is 4, so r has to be 2. My radius is 2. Okay? So we're going to draw our center at -1, 0. And my radius is 2, so I'm going to, again, in every direction, I'm going to go 2, draw me some little points there, and then sketch out my circle. Okay? So what I meant was if my circle was on the origin, the center's on the origin, then that means H and K are both 0. That's how we would use that standard equation even there. But usually you'll just see an equation x squared plus y squared equals some number. Okay? And you know it right away if your H and K are gone, meaning they're 0, then it has to be at the center is at the origin. Okay, now we're going to look at going the opposite direction. I'm going to give you a graph and you pull out the equation. Alright, let's look at an example. Hopefully I didn't draw it too small. Hopefully you can see. Now again, in order to draw our equation or to make our equation, we need those same two parts, the center and the radius. So we're going to pick that out of our picture. You look for your center first. We see our center here is going to be at x equals 0, y is -3. So we're at 0, -3. That's our HK, remember. Okay? HK. And then we count from our center to the circle to find our radius. So we make sure that it is the same each way. Count 1, 2, 3 down from here. So my r equals 3. Now using my standard equation, you start with x minus h squared plus y minus k squared equals r squared, and plug in what we found from our picture. We wind up with x minus 0 squared, y minus -3, which gives us y plus 3 squared, and then don't forget to square your radius or your r equals 3 squared. We're going to go ahead and simplify it a little bit. We're going to leave it in the form y plus 3 squared just so that we can recognize that it is a circle from the equation, but we do get rid of our 0 if we wind up with that. So x squared plus y plus 3 squared equals 9. That's going to be your answer for me. The equation of this circle. Now let's look at one more where I'm not going to give you the graph, but I'm going to give you the details. Let's see how we work that one out. Alright, ready for question 2. What do the variable h and k stand for in the standard equation of a circle? Alright, let's look at the next example. This one's a little bit harder than the last one. Let's work through it together and see how we do. The point -1, 2 is on a circle whose center is 2, 6. Write the standard equation of the circle. Okay, now we talked about the two things we need in order to write an equation. We need the center and we need the radius. Now the center they gave us, they told us the center is at 2, 6. So we're good there, but we don't have a radius. Okay, so if you remember from earlier what a radius is, it's the distance from the center of our circle to a point on the circle. Well, fortunately, they gave us a point, -1, 2, that is on our circle. So if we can find the distance from our center to a point on the circle, we actually will have our radius. Now, since we're graphing, these are points on a graph, the distance between the 2 points is going to be our distance formula. So let's pull that back out from earlier today. x2 minus x1 squared plus y2 minus y1 squared. We take the square root of both, and let's fill these in. We wind up with -1 minus 2 squared. 2 minus 6 are my y values. We wind up with -1 minus 2 is -3 squared is 9. 2 minus 6 gives me -4 squared, which is 16. We wind up with a nice square root of 25 is going to be my distance. That's my radius. Square root of 25, which is 5. Should shorten that. And now we take that to our equation, our standard equation, which again, x minus h squared plus y minus k squared equals r squared. We're going to fill these in. My center is hk, so I wind up with x minus 2 squared plus y minus 6 squared equals r squared, so that becomes 25. There's my equation for this circle. Got one more example. Okay, here's our last example. It's a little different from the other ones. Let's do it together and see how this is done. Okay, 3 forest ranger stations are at A, -3, 2, B, 2, 2, and C at -1, -1/2. So our graph is representing an area of land, and they're giving us the coordinates on the graph, telling us where each ranger station is. Ranger station A, B, and C. And I said a fire is 2 miles from A, 3 miles from B, and 3.5 miles from C, but they don't have any direction of where this fire is. So the idea is, can we find the location of the fire by graphing what we do know? So the idea is we know how far away from each of the stations the fire is. So if we draw a circle with that radius, we're going to see kind of like a circle of influence, and where they all meet, where they all touch, that will be where our fire is. That's what we're looking at, okay? So A is at -3, 2, and it says the fire is 2 miles from A. So I'm going to draw a circle around my fire station, or my ranger station here, that has a radius of 2. Okay, so there's my first one. I'm going to use a different color. And then we have at B, it's 3 miles from B. B is at 2, 2, so we're going to go ahead 1, 2, 3 here, 1, 2, 3, and 3 that direction. So we wind up with a nice circle there. And the last one, you can probably already see it, but we'll draw it anyway. 3.5 miles from C, so we go down here, half, 2, 3.5, 1, 2, 3, and then 3.5 that way. We draw our circle there. Now if your question is asked, this time they do happen to touch at a single point. Sometimes there's a little bit of overlap, and then it gets interesting depending on what your question is. But we can find that our fire is right there where all 3 circles overlap or intersect. Okay, I have a couple of problems like that using this idea. Okay, that finishes our lesson and finishes our chapter. We have a few days of review before the test next Monday. So we're ready for our joke of the day. I think it's a cute one today, hopefully. Okay. Why did the inches obey the yardstick? Because he was their ruler. That was a cute one. Okay, I'm probably going to run out of jokes before the end of the year, but I hope not. Hope you guys have a good day. Do well with your homework, and I'll see you soon on Zoom.